For wisdom is more precious than rubies, and nothing you desire can compare with her. Reads Proverbs chapter 8, verse 11. Good morning to one and all present here. With hearts filled with gratitude to the Almighty, we gather today to celebrate knowledge, innovation, and collaboration in the field of chemistry. Science begins with curiosity, but it flourishes with wisdom, and today's program stands as a testimony to that truth. A very warm and respectful welcome to our esteemed dignitaries, learned speakers, faculty members, research scholars, students, and all participants to this auspicious academic gathering. Chemistry reminds us that small changes at molecular level can transform the world. To mark the beginning of this academic event, may we invite our dignitaries to light the ceremonial lamp, symbolizing knowledge, dispelling ignorance. I now invite our Secretary, Reverend Dr. Sister Ignatius Mary, to light the first wick of the lamp. Followed by our Vice Principal, Dr. Sister Arun Lady, Dr. S. Sukumari, Head of the Department, and our Chief Guest, Dr. Karthik Kumar and Dr. Babiola, to light the lamp. Thank you, esteemed dignitaries, for enlightening this occasion. To invoke the divine blessings upon this program, I invite the Chemistry Students Choir for the prayer song. Thank you, dear students, for the soul-stirring song. Now, to formally welcome this August gathering, I invite Dr. S. Sukumari, Head Department of Chemistry, to deliver the welcome address.
This is the day that the Lord has made. Let us rejoice and be glad in it. Psalm 118, verse 24. A warm welcome is the molecular spark, the precise catalyst that ignites this formal gathering into a high-velocity powerhouse of collaboration. Respected chief guest, distinguished delegates, eminent speakers, dear faculty members, and curious students, good morning to one and all. I feel truly happy and honored to welcome all of you to this international conference on sustainable nano and AI-linked innovations for next-gen healthcare, SNILE 2026. This esteemed event will serve as a global forum to explore groundbreaking advancements, transformative ideas, and innovative applications within the field of chemistry. From fundamental research to practical implementation, this conference will demonstrate how chemistry transcends traditional boundaries, addressing some of the world's most pressing challenges. Today, we gather at the intersection of three transformative frontiers: green chemistry, nanotechnology, and artificial intelligence, which together are redefining the future of precision medicine and patient care. And this event is a hybrid event that comprises both an in-person and a virtual congress. It is a profound honor to stand here to welcome a respected, inspiring personality, a visionary philanthropist, a meticulous disciplinarian who does not just occupy an office, but truly defines the backbone of this institution. It is none other than our vibrant and tireless secretary, Reverend Dr. Sister Ignatius Mary. Sister is a multifaceted personality. She is an eminent scholar, excellent teacher, great academic leader, and very efficient administrator. Her academic journey is as fascinating as it is diverse. While we know her as a brilliant professor of English with an MA, MPhil, and PhD, many are surprised to learn that she began her journey with a UG degree in chemistry. Her thirst for knowledge is unquenchable, spanning PG diplomas in journalism, intercultural studies, and specialized PG course in teaching of English from Central Institute of English and Foreign Languages, Hyderabad. She is a true polyglot, fluent in 5 languages: Malayalam, Tamil, Hindi, English, and French. Under the visionary leadership of Reverend Dr. Sister Ignatius Mary as a principal from the year 2001 to 2007, she led this college to be recognized as a college with potential for excellence by UGC. During 2006 NAC visit, she has taken our off-campus spaces to the next level. Beyond bricks and mortar, she has built a legacy of the heart by establishing endowments in the names of former principals and secretaries. She has secured the future for generations of students. Some people retire from work, but she simply refined her mission to become the heartbeat of our student community. Even now, after assuming the role of secretary in the year 2024, the campus is undergoing a massive transformation. No detail escapes her. No detail is too small. We can still find her meticulously inspecting every nook and corner, ensuring our infrastructure is not just maintained, but perfected for your learning and environment. She is a tireless force of nature, bringing sunshine to our offices and a green revolution to our campus. Her vision aligns perfectly with the green objective of this international conference. And true to the proverb, the true meaning of life is to plant trees under whose shade you do not expect to sit. She has personally planted the greenery that breathes life into our campus today. She doesn't just nurture minds, she nurtures the earth itself. My heartfelt welcome to our hardworking, compassionate, and eternally energetic secretary, Reverend Dr. Sister Ignatius Mary. Welcome you, sister. Behind every successful event is a driving force, and we are honored to welcome our esteemed principal, the mentor, the motivator, Reverend Dr. Sister M. Fatima Mary, whose constant support and motivation fueled this achievement, and whose belief in us turned can we into we did today. Welcome you, sister. I extend a gracious and glowing welcome to our ever-supportive, young and energetic Vice Principal, Reverend Dr. Sister J. Arulmeri, whose guidance, wisdom and unwavering dedication continue to light the path of our college's glorious journey. Welcome, sister. We are highly delighted to welcome our guest of honor, Dr. S. Karthik Kumar, who is a distinguished scientist at the Apollo Hospital Educational and Research Foundation in Hyderabad. And serves as the ambassador for Student Network on Extracellular Vesicles, Interconnect Program, International Society for Extracellular Vesicles, USA. He is serving as founding executive board member, IEVS India, from 2023 onwards, and contributing to the Indian Extracellular Vesicle Society, industrial and academic initiatives. He also contributes his expertise as a scientific advisory member for the EV-based startup Sapphire Innovations. His academic journey is truly inspiring, with the MSc from Sri Venkateswara Institute of Medical Sciences University, Tirupati, and PhD from Shastra Deemed University. His vast research in diagnostics and immunotherapy for cancer management has earned him prestigious awards, including the Apollo Best Performer Award for Research and Innovations, and an international award from the American Chemical Society for paper presentation on extracellular vesicles. He had also featured in an exclusive interview with Shastra magazine, IIT Madras, for EV Science and Technology Innovations. He is also a recipient of Best Employee Award, Apollo Hospitals Research Foundation, and Council of Scientific and Industrial Research, SRF. He is the co-investigator of DST project grant of 95 lakhs for AI integrated dementia detection. He has also delivered invited talks in many national and international conferences and presented numerous papers in international conferences. We are truly honored to have you, Dr. S. Karthik Kumar sir, amidst us. On behalf of our Fatima family, we welcome you, sir. We are greatly delighted to welcome back one of our own, Dr. Babiola Suserat, a prominent alumna. Dr. Babiola is currently a postdoctoral research fellow at the Comenius University, Slovak Republic. We are deeply grateful that you joined us today despite your busy international schedule. Your global research journey is a source of great pride for this institution. Welcome back, Dr. Babiola. On behalf of your Fatima family, we welcome you. I extend my warm and sincere welcome to Dr. V. Dharmaraj, Research Scientist, Institute of Clinical Medicine, College of Medicine, National Cheng Kung University, Taiwan, who is going to deliver invited lecture in the afternoon through online. Then I extend a sincere welcome to all our participants, including enthusiastic faculty members, hard-working research scholars, and curious students joining us both online and offline. I would like to extend a special welcome to my dear staff members who put in countless hours of hard work and dedication to make this event a success with their unwavering support. And I am grateful for your commitment and enthusiasm. Welcome all faculty members. And my warm and special welcome to my dear budding chemist, energetically well-defined students. Your presence will make this event truly special and meaningful. I would like to extend a heartfelt welcome to all our technicians and non-teaching staff. May this conference be a fruitful platform for learning and innovation for everyone involved. Your presence turns this event into a vibrant hub of futuristic ideas. As we begin, let us explore how the convergence of nano and AI can create a smarter, more sustainable healthcare ecosystem. Once again, I welcome you all for this conference. Thank you.
Thank you, ma'am, for setting the tone of the conference and welcoming us with clarity and warmth. In recognition of the valuable contribution and to commemorate this occasion, we are pleased to present a memento as a token of our heartfelt gratitude. As a symbol of growth and gratitude, we present a sapling in a pot as a memento to our respected sisters. May I request Dr. Sister Arul Mary to present the memento to our Secretary, Reverend Dr. Sister Ignatius Mary. We now invite our department head, Dr. S. Sukumari, Associate Professor, to honor our Vice Principal, Dr. Sister Arul Mary. May I now invite Reverend Dr. Sister Ignatius Mary to do the honors to our esteemed chief guest, Dr. Karthik Kumar. I kindly request Dr. Sister Arul Mary to give the memento to our chief guest, Dr. Babiola Ann Sesuraj. Thank you, dignitaries, for your gracious presence. An institution grows stronger when guided by visionary leadership. I now request Reverend Dr. Sister Ignatius Mary, Secretary, Fatima College, to deliver the inaugural address.
Respected Principal Dr. Sister Fatima Mary, my affectionate superior Sister Arul Mary, Honorable Keynote Speaker Dr. S. Karthik Kumar, vibrant and innovative scientist of Apollo Hospital, Educational and Research Foundation, Hyderabad, and Ambassador Student Network on Extracellular Vesicles, USA. Knowledgeable and efficient technical session speakers, Dr. Fabiola Ann Sesuraj, Comenius University, Slovak Republic, and Dr. Dharmaraj Vairaperumal, research scientist, National Cheng Kung University, Taiwan. Dedicated convener, Dr. S. Sukumari, head of the Department of PG and Research Department of Chemistry, committed experts of organizing committee who worked collaboratively to plan and execute the event, enthusiastic participants from other institutions, and my dear students, a very good morning to you all. At the outset, I congratulate Dr. Sukumari and the members of Chemistry Department for organizing an international conference that would enable knowledge exchange, professional networking, career advancement, to share latest research, foster collaborations, and address shared challenges. This international conference focuses on a transformative development and critical challenges in green chemistry, nanotechnology, and AI innovations shaped by global scientific advancement and evolving scientific demands. As the need of the sustainable solutions and innovative technologies continue to grow, this event will serve as a platform to explore the interdisciplinary intersection of green chemistry, nanotechnology, and AI innovations for next-gen healthcare. The convergence of sustainable nanotechnology and artificial intelligence is catalyzing a new era of next-generation healthcare, focusing on eco-friendly materials and data-driven precisions to enhance diagnostics, drug delivery, and patient monitoring. This synergy addresses the need for high-performance, personalized medicine while reducing the environmental footprint and toxicity associated with traditional, non-biodegradable, or toxic synthetic materials. I am sure that this international conference would enhance collaboration between academics, industry leaders, and policymakers to address global challenges in health, energy, and sustainability. As we are aware that sustainable chemistry is the design, manufacture, use of efficient, environmentally benign chemical products and processes that prevent pollution, minimize hazardous substances, and rely on renewable resources. Sustainable chemistry in healthcare focuses on designing medical products, pharmaceuticals, and processes that minimize environmental impact, waste, and hazard while improving patient outcomes. It utilizes eco-design, green chemistry principles, and safe by design approaches to reduce carbon footprints, manage water, and ensure safer, sustainable, and accessible medical technologies. Nanotechnology, a field that uses materials at the atomic and molecular levels, has fed the way for the growth of nanomaterials, including nanoparticles, nanoprobes, and nanosensor. In particular, these substances were incorporated into biological systems for very selective targeting to improve the specificity and efficiency in medicine. The particles now have acquired a significant role in imaging and drug delivery methods with the capacity of very early detection and treatment of diseases. Cancer is highly detrimental and fatal disease that poses a significant threat to human well-being. The pattern of cancer treatment is continuously being optimized by the advancement of old treatment approaches and the invention of novel treatment modes. Nanotechnology based approaches are emerging as powerful candidates in the development of these advanced methods for treating tumors. With this breakthrough in nanotechnology, AI in health care can witness rapid progress, especially in medical imaging, diagnostics, and personalized treatment planning. Apart from diagnostics, AI has an equal critical role in optimizing treatment by predicting how patients will respond to specific therapies, allowing any changes to be made to the treatment regimen on a real-time basis. I am very happy to inaugurate this international conference on sustainable nano and AI-linked innovations for next-gen healthcare. This conference is capable of exploring the sustainable innovations significantly impacting healthcare delivery by improving access to care, reducing cost, and enhancing the quality of care. Telemedicine provides remote healthcare services using technology, improving access to healthcare in rural areas, and reducing the burden on healthcare infrastructure. The integration of nanotechnology with AI can improve the accuracy and accessibility of patient data, providing health professionals with a comprehensive view of patients' medical history, enabling more personalized and effective care and reducing errors in diagnosis and treatment. This conference has a potential to revolutionize healthcare by improving diagnosis, treatment, and patient outcomes. Congratulations to the department for convoking such productive and inspiring events, leading to fruitful discussions and innovative researches. Your hard work and dedication are truly admirable. Wishing you continued resounding success and best wishes. Thank you all.
Thank you, sister, for your inspiring and motivating words that strengthen our academic spirit. Chemistry today stands at the intersection of sustainability, nanotechnology, and healthcare. To enlighten us further, I proudly invite our chief guest, Dr. S. Karthik Kumar, scientist, ISCV USA, to deliver the keynote address.
Very good morning, everybody. So it's my pleasure to be here this wonderful morning. And it's a beautiful campus, firstly, and we had an excellent morning here. Especially, firstly, I would like to thank Sukumari ma'am, Professor Sukumari ma'am, and Dr. Vinusha ma'am, and entire chemistry department who has organized this beautiful conference. We were also just discussing yesterday about this conference. So we go the conference wherever generally we see either biology. In the biology, if you see specific divisions like cell biology, molecular biology, etc., molecular diagnostics are very core thing. If you go chemistry, if you see like green chemistry, synthetic chemistry, in that again one part synthesis, something like that. So you are able to capture the content specific to the particular subject. In the subject, you will have again sub areas. That is what generally you see in the conference. Let's say I know more about biology. If you go cancer diagnostics, you're able to learn only about the cancer diagnostics. But now people are realizing that there is a lot of gap between basic research to translational research into come bedside. So where it is coming, our understanding, our learning level, we are since specificing to the only one area, this kind of gaps are more exists. Let's say I do the purely cell biology research, you do purely chemical research, another one will do the some medical research. Who will merge all these three things? Although we have published data patents, but carrying forward the same area or same molecule, we are lacking actually. Now people are realizing that there is a need for interdisciplinary research, and several things also proposed by European Molecular Biology Laboratory and very big organizations. Similarly, this is the unique platform. This conference bridges various areas, starting from cell biology, cancer diagnostics, to green chemistry, to AI related things. So today I am very happy to be part of this conference to deliver something on cancer diagnostics and therapy, which our lab purely focusing on. So this is about my brief introduction. Already I think Sukumar ma'am introduced, therefore I am not going into the much details. Next slide. So today as my topic is advanced cancer diagnostics and therapeutics using the platform called extracellular vesicles. So what are the extracellular vesicles? You might be wondering. Those are nothing but nanoparticles which release from the cells. Any kind of cell you take in our system, blood cells, fibroblasts, heart cells, whatever it is, every cell will produce these extracellular vesicles to communicate with other cell. So while they are communicating, they bring the scoop of cytoplasm. It means cellular compound that we are able to detect, means we could able to judge the thing which is happening in the cell. Those things we will discuss in the later slides. So firstly, since the topic is on cancer diagnostics and therapy, which we are doing, initially let's see why do we need this cancer research. There are a lot of subject areas are there. There are a lot of other fields are there. Why we need to focus more on cancer? I'm not mentioning that other fields are less effective. Equally, they are also very important. But why need to stress more on cancer? So here we have certain reasons. So if you see there, so almost 20 million cases are affected worldwide by cancer according to 2022 global cancer estimates. You can see almost half of them were shown to die. The mortality rates were very high compared to other diseases. And it is very much predicted by WHO and World Cancer Agency that 1 in 5 people can develop a cancer in going forward due to maybe the several reasons, maybe environmental factors, mutations, radiations, stress, whatever it is. Though we have the best medical systems to diagnose and treat, but what happens is these cancer cells often undergo to develop the resistance to respond to reduce the effectiveness of the drug. That is where problem comes. If you take the drug, person will respond. If you give the drug, person will respond. But what happens after 2 to 3 months? Same drug will not work effectively because these cells will often practice to that drug. They will practice how to beat the drug effect. That is where many people undergo seven stage end into the die. So it once the cancer is affected, we all know that. So it is a kind of lifelong burden. But however, we have certain beautiful things made from past several years for particular cancers. Let's say previously breast cancer is also one of the very danger thing. Now we made it possible that we can cure the breast cancer. Almost we can say complete cure. Like with the breast cancer surgery, after the surgery, if we have the effective chemotherapy treatment, person can live with that. Actually, it is not a problematic. The relapse is very less after the surgery. With the breast cancer we have success this, but what about other cancers? So we are midway to treating those cancers still, especially like if you say brain cancer, it is called glioma. Once the person get brain cancer, his lifespan is almost about hardly 2 to 3 years. Such a deadly disease is cancer. Therefore, we need to learn more about cancer, irrespective of the research and science, whatever we are doing. It is also need for the general awareness. So that is where this cancer comes majorly into the picture. So we are also very happy that I think recently government is also announced Padma Shri for 2 doctors from Hyderabad region itself. I think many more in the entire India. So people are also recognizing the work which is doing by clinicians and cancer researchers especially. And this is the some before slide. So here we can see in 2000 we have 10 million cases, 2022 almost double. Those are the estimates by statisticians. So by 2050 it will be even more higher. So how far we work to reduce this burden and diagnose better is really a very good challenge, and it will be interesting to make some of the new products to combat this. Next slide, please. So faculty members might be knowing this, and especially for the students, this slide is. So what is cancer? So we'll be talking more often, like he got cancer, he has more of the tumors or something like that. So what is cancer or what is tumor? If we see what happens in our body, every cell has a certain lifespan. Let's say, to say an example, one cell born today, it will be staying for 5 to 7 days. It do all the functions required, then it will die. Then new cell will come. The cell amount in the body would be same. How these cell numbers are maintaining majorly by 2 ways. One thing is apoptosis, which is the programmed cell death in our body. It means those are some of the molecules will check the cellular count and their life. So once they are having done their job and their life is over, they clear actually. So that is where apoptosis occurs. Once this apoptosis is not happening, it means not able to clear the cell. Those will settle more and more in the particular tissues and make a one kind of fibrous cap or bulge. That is called tumor, we call it. Once this is apoptosis, which is nothing but cell death is not happening, nearby cells have more power to even higher to make it more and more generation. They proliferate more, it make it even worse. That is where cancer starts with a small tumor, but it will go with a higher and higher proliferation later stage. They also start moving from one place to other place of the body, that we call it as a metastasis and higher grade thing. So this is, we call it as a cancer. How this is happening, if we see maybe the chemicals, radiation, obviously certain kinds of high levels of reactive oxygen species from stress, growth factors, mutations, and cell death pathways, etc. Compared to previous years, if we see now, this has been increasingly increased. So though reasons are we are not able to decode completely. So one thing which is in our thing, our hand is so to keep it ourselves less stress and have a healthy dietary things and to make it ourselves happy, which is not only for the cancer, which is to make ourselves healthier forever. Yeah, please, next slide. So now we understood what is cancer. So how to diagnose this cancer? So you might be knowing once any person get the cancer, whom you know or whatever in general. So they go to the hospital, they do some blood test. They say there is some kind of cancer signs we are seeing, and we collect the piece of the biopsy. Let's say they are suspecting that person having the oral cancer. They take a small piece of the lesion where we are seeing lesion is nothing but one kind of pulp structure that they take a piece of it, they send into the diagnostic laboratory. Histopathology people will cut that small piece and stain them with cancer specific proteins. Let's say P53, one of the markers, if we assume, I'm saying theoretically. So this P53 stain, when they do, it is have tendency to bind to the cancer cell specifically. If the cancer cells are more stained, they confirm it as a cancer. Though liquid biopsy, blood-based tests, or even saliva-based tests are available, they are only mainly used for the screening purpose, not to confirm. So person has to go for tissue-based test to say more, to confirm it actually. So the thing is, once we detect this cancer using the tissue biopsy, that's not a problem. Person can give a piece of tissue to get a better results. But how to track this disease? Let's say he confirmed with the cancer, though they started the treatment. So doctor wants to know how the treatment is happening after 2 months, 6 months, 1 year. Every time it is very difficult to get the biopsy tissue. Even person will not be willing to give more and more. Already cancer people will be having a lot of, they'll be giving a lot of blood for tests one way. Another way they are sick. They are also not in mood to give it very happily. So that is where even sometimes they don't go much of the visit to the doctor since they have to give this more often. That is where these liquid biopsy tests come into the picture more nowadays. And you might wonder, so if the tissue is that much problematic to track the disease or to give more, why can't they give just a blood? Why we stopped with only screening? Why it is not a confirmatory? The problem is blood when you take, we are able to screen it. Why it is not went to after confirmatory? If we see the sensitivity, which is to confirm cancer as a cancer, is around 60 to 70%, not the 100%. To reach the 100%, now a lot of research is happening. In that way, some of the nanotechnology based things, the extracellular vesicles, which we are using also come into the picture. So now blood test is there, let's say. From the blood, they detect certain proteins. They say it is a cancer specific protein, it is higher. But why it is having the less sensitivity or specificity? If we see, these proteins, some of them also presents in the normal cells and also in the system. So when you detect, there is a lot of background noise, which is in turn leads to the some of the signal problem actually. Let's say it has to come the, if you do your, you might be more aware of spectrometry, all these things. So if you do the spectroscopy reading, they will have a cutoff that if it crosses 2, we can confirm as a cancer. But what happens is the irregular proteins, which other than that protein present in the blood, will nullify the signal sometimes. It will be giving like 0.9 or something, not 1. That time lab technician or clinician will be wondering whether to confirm as a cancer or not. That is where this test lacking the sensitivity. Now the lot of research is towards making more sensitive and specific tests for cancer confirmation and also the prognosis, how treatment is happening. So that is where this liquid biopsy test, liquid biopsy is nothing but using liquid to confirm the cancer rather than going for a tissue. It may be a blood, it may be saliva, urine, and also yeah, blood or saliva. So the modern diagnostics now focusing on various things, but in our lab, we work on exosomes. Why we work on exosomes, all these things we will see in the upcoming slides. Yeah. So now it is a major interest of chemistry students especially, You might be thinking, okay, interdisciplinary, we have three different talks. How it is related to us, why we should learn other than the general perspective. If we see the test which we use in any of the diagnostic or any of the laboratory, they have a strong background or backbone of chemistry people. How does they develop a test? So there are three major different ways to diagnose any disease, including cancer. First one, we detect certain proteins related to the cancer. How we detect them? Using the platform called ELISA, enzyme linked immunosorbent assay. So previously the old method is using only certain antibodies and make it them to react with the antigens which you have in the sample and get a color. But now the trend is to coat these antibodies into certain chemical structures like AU nanoparticles, let's say, where it comes from, your material chemistry or synthetic chemistry. These nanoparticles will be conjugated with the peptides or antibodies of interest and make like this kind of a platform. You just add your saliva or blood onto that. What happens is this chemical based platform will detect only the cancer specific proteins, it leave other proteins. That is where you can develop your more sensitivity. Now, as we discussed previously, the sensitivity will be higher because you are nullifying the unnecessary signal. So that is where your chemistry is more important. That is where sensitivity will also increase. Other than proteins, we use the PCR based test. It is a mRNA. Now you might be knowing very well because of COVID actually. So COVID tests all are like SARS COVID tests. So they detect RNA. So how you're detecting that RNA? That is using the some of the chemical fluorophores or probes. So you will be having certain probes designed to bind these mRNAs. These mRNA is nothing but ATGC. So that probes will go and bind particularly to the cancer specific mRNA only, who are giving that specificity, not by the biologist, by chemists like you, or developing them and giving to test it or giving for the application to the biologist. They take forward this test. If they having satisfactory is okay, otherwise they have to come back to the chemist or they have to come back to the medicinal chemist or whatever, and they will rectify those probes to make it more better, and that is where we will come into a more productive way. And this is something very new, so we can also directly stain the cells in the tissues using some of the chemical probes. What happens is, this again also based on the enzymatic things, they go and degrade some of the substrates within the cells. What happens is, when they degrade, they develop some color. When the color is developed, your cell will be fluorescent in nature. It will be like, let's say for, it is in a green color, you will see in the tissue. The advantage is we have seen initially tissues we cannot do more often, but now what the chemistry based technologies are showing, not only we can diagnose, we can also use these probes to kill the cancer cells. What happens is, while they generating this fluorescent signal, they also generate the molecules called reactive oxygen species. They are very effective in killing any of the cell, but these probes which is developed are specific to the cancer cells. They go inside of the cancer cells. They also give the diagnostic and therapeutic thing together. They will give a color signal, you will confirm as a cancer, and also those signals are internalized in the cells, and with the more amount of reactive oxygen species, they also able to effectively kill the cancer cell. I think that is called photodynamic therapy. Our next speaker will be speaking on that. So there is no wonder chemistry always linked to the healthcare. It is much required to do a lot of interdisciplinary research to make the product or diagnostic thing from basic to the bedside. Yeah, next slide. So now we have seen how to diagnose the cancer. Now, if we go to the next part, which is how to treat the cancer, you might be knowing that initially they'll be giving the drug that is called chemotherapy, initial treatment. Once the person is responding to the chemotherapy, they will be very happy. But most of the times, what happens is after a certain months, they stop responding to the chemotherapy. Then they start something called immunotherapy. Immunotherapy is nothing but using drugs to train the immune cells in our system. Like you might be knowing T cells, B cells, natural killers, all these things are available in the blood as well as inside of the tumor. This tumor, how it makes after developing, generally these immune cells have tendency to kill the cancer cells, but these cancer cells such a way manipulate those immune cells and make it help them to grow more and more instead of killing. That is where we also give the immunotherapy after the chemotherapy they are not responding properly, so immunochemotherapy would be a next option. Next, also they go for radiotherapy. If person is not responding even immunotherapy also, they go for giving the radiation. Radiation is nothing but using the radiation to kill the cancer cells. But when you give the radiation, also nearby cells will die, normal cells. That is one of the side effects. Even you take the chemotherapy, not only the cancer cells, some other cells also will die. That is where generally reported as a abnormality, side effects, you say it actually. So these are the general methods people use, and nowadays there is also the one technology called targeted therapy. Why these drugs are giving the abnormalities? If you see specifically, let's say you take a cancer drug, paclitaxel or doxorubicin, which are mostly used in the cancers as a first line therapy. These drug molecules will not only go into the cancer cells and kill the cancer cells, also they damage the nearby cells. Theoretically to speak, if you give it 10 molecules of doxorubicin, hardly only 2 to 3 only will go to the cancer cells and make them kill. What about rest of the 7? They accumulate and they cause certain things of things. That is where this targeted therapy will come into the picture. In the targeted therapy is nothing but name itself, it is there to target cancer cells effectively and make them to kill other side, other cells should not be affected. That is the concept. Targeted, it should specifically till only the cancer cells. How they make it? That is through certain kind of nanotechnology platforms, including exosomes, which we are working. What they do is they take this drug and put it in this nano platform. It is like a baggage you can consider, so you will keep all your stuff in that bag. When you give this nano drug into the patient, this nano drug, nano carrier, we can call it as a carrier. So this carrier will take the drug into particularly the tumor area and deliver this drug into the tumor cells. How this happens? You make a certain carrier, you give the cell specific ligands, we will call it as a, it is like one kind of marker. You keep it on this drug delivery system. That ligand will act as a messenger, particularly go to the cancer cell. Cancer cell, every cell have a receptors on them. These carrier, when go to the cancer cell, they together respond. It will decide whether to take this drug into inside or not. If it is only cancer cell, accepts. If not a cancer cell, it simply rejects. That is where the immunotherapy, sorry, other than immunotherapy and chemotherapy, we are targeted therapy. Of course, we are seeing very good results. It will say costly and many of them under now validation stage. So other than this, we have an option of surgery, but not for not widely used this until it become extent. But breast cancer, certain cancers, it is very successful. And bone marrow transplantation and hormone therapy, they do rarely for only specific cancers, not widely used. That is depends on the type of cancer which they treat. But again, as we discussed a lot, toxicity and drug resistance is the major concerns in the treating of the cancers, and that is where clinicians find hard to get survival rates to increase more than 5 years. We are able to improve the outcomes, we are able to improve the survival rate, but at what extent? Only 5 to 10 years. So that is where we are also working a lot on giving some of the therapeutic solutions or approaches. So that is where your medicinal chemistry is also coming to the picture. So whatever we use the molecules, where it comes from, the chemistry or medicinal chemistry people exclusively synthesize the new molecules which have lot of capability to bind to the cancer cells effectively. Then we take them and we do it as an application. If they are if we are finding they are very good, then we start loading them into nano based platforms to enhance the efficacy. We are not making the molecules, we are making the use of that molecules more effective using biological approaches. But again, your chemistry is the very strong and base to make any therapeutic things. If you take major drug companies, take Reddy's, Divi's, Cipla, or whatever, they have chemistry as a major because they are into the drug marketing. Next slide. So, where we are now in cancer? Now you heard all these diagnostic therapy related things. Yet now, where we stand, if we see, so now we have a certain advancements in the liquid biopsy for molecular testing. We are able to also track the disease using these blood and saliva-based tests without more relying on the tissue biopsy. We cannot say it is an alternative. We have reduced the relying, but still we are validating and we are making more precise to bypass this tumor tissue. So now we have an added advantage with this liquid biopsy test, but we cannot bypass the tissue at the moment. We have done whatever the test, maybe using exosomes, protein, or mRNAs using liquid biopsy. Some of them are showing good effect, but they have done in a less patient samples. Let's say taking 100 patients, 200 patients. That is not enough to generalize these findings and deploy into the clinics. So they are mostly into the validation stage. That's what you would see here. And we also made some of the customized treatments as we discussed previously, like immunotherapy, targeted therapy, etc., which previously we do not have. With that also, we are able to see very good trend in outcomes and early detection also possible, especially using this liquid biopsy test. We can screen many people, like thousands of people using a simple test. If you find any abnormalities in few people, like let's say 100 out of 30, those 30 people only has to undergo for tissue biopsy. Instead of screening 100 people using tissue, it will be cost burden and time taking everything. This liquid biopsy based screening test we are using, that would be a very good advancement. And targeted therapy we discussed previously. And the major thing now where we are focusing, if we see nanotechnology. So we have several nano-based platforms like liposomes, hydrogels, extracellular vesicles to use them as a drug carriers to enhance the effectiveness of the drug and reduce the toxic effects onto the other cells. But why we are using this exosome? If we see these are comes from the biological origin, they have less tendency to cause any internal immune reactions. So that is where we are using these exosomes. And if you see precisely what is this extracellular vesicle or exosome, I may be speaking sometime exosome, sometime extracellular vesicles, you might be confusing. Extracellular vesicles are the particles comes from any cell. While coming, they have all these markers. If you see here, some of the proteins, some of the DNA, some of the nucleic acids, etc. They also have some space within them, if you notice. If you take it this from the cancer cell, if you analyze those proteins, mRNA, or whatever the cargo, you are able to tell what's happening in the cell. Since they are coming from the cancer cell, but we can capture them through the blood or saliva without disturbing the tissue. If you analyze this within the blood or saliva, urine, you are able to tell the status of the cancer, what is there. Since they also have the space, if you see the word where I have written exosomes, with that space, we can use to load the drugs and we can give to the patient. So we can use them as a diagnosis or therapy together. If you load the drugs and give to the patient have more capability to take those exosomes into the tumor level because they are coming from the same source, unlike other chemical or metal particles which they use often. That is where this has become a very fantasy from past decade. Yeah. Maybe you can put. So now if we go to the little more details, what are these extracellular vesicles? So from cells, we will see three different kind of secretions as a form of vesicles. Vesicle is nothing but round shaped structures. Inside they have some material. Cells will release mainly three different kind of these vesiculars. Number one are exosomes, which are very smaller in size. And if you see in the picture, while coming, they carry some proteins and RNA, all those things. So they have the cell specific cargo. They are in the range of 200 nanometer in size. If you detect them using nanoparticle tracker or transmission electron microscopy. And second type of vesicles are microvesicles. They are little higher than the exosomes. They have the information about the cancer cells, but compared to exosomes, they have very less. But why they have very less, we will see next. Last type of apoptotic bodies, which we know that When cell is undergoing apoptosis or some damage, they release these apoptotic bodies. They are in very bigger size. They are more related to the apoptotic markers, not useful much for the any disease diagnosis. That is where we use these exosomes as a platform for diagnosis. Please, next. Yeah, next. So if we see the biogenesis of these exosomes, biogenesis is nothing but how they produce. So I'm not going so much into the biology. So they produce inside of the cell. While producing, they roam around the cell and take the little piece of content which is available in the cell. Let's say it is going from this corner to that corner of the cancer cell. They capture certain cancer related proteins responsible for the growth of that particular cancer cell, and they will make it as a pack. You consider as a pack. That pack will be coming into the out of the cell. You would see here exosomes are coming from the cell. The advantage is these, when these come from out of the cell, they enter into the nearby biological fluids. Let's say if they are coming from heart, they enter into the blood slowly. It is a systemic circulation. Since for suppose person having a some UTI problem or urinary related cancer, they enter into the urine. Person having a head and neck cancer, maybe oral cancer, they enter mostly into the saliva since it is the nearby place. But in blood, we are able to detect these exosomes in every cancer. However, compared to blood, if you take the fluid which is near to the cancer site, person having the oral cancer, if you take a saliva, they have more amount of this cancer specific cargo, and sensitivity is also found to be very higher. Let's say blood cancer, blood is good, saliva is good for oral cancer. Some of the bladder cancer, you can consider taking urine instead of going for blood. So these cargo, when we decode, we are able to see the information of the cancer cell. That is where we not only detect the cancer. Let's say you take these exosomes while giving of the chemotherapy and detect certain protein, or you consider that reading or whatever the signal is coming. Let's say assume that the spectroscopic reading of this exosomal protein is 1. You give the treatment and diagnose these exosomes by simply taking from the saliva after 3 months. What happens is, if person is responding to the treatment, that reading will start going down slowly. That has been observed. Maybe person is a higher grade, these exosomal proteins will be higher. Lower grade, it will be compared to be lower. That is where we can track this disease using these exosomes, not only just to detect or diagnose. The person is responding to the chemotherapy within the cell, these cancer specific proteins will go down. That reduced proteins will be captured by exosomes and bringing into your fluids, saliva. If you take saliva, if you detect, you are able to capture what is happening in the tumor tissue. Yeah, next. But we also have the certain advantages of using these exosomes. Other than saying the word more often, as a liquid biopsy test, we can detect easily. Other than that, also we have certain very acceptable advantages in the medical science. The number one is they reflect the tumor condition, not with low sensitivity or specificity. They reflect the tumor condition with a very good sensitivity of more than 80%, which is very good if you have a liquid biopsy test. And also the specificity found to be more efficient. Other than that, they represent the entire tumor microenvironment. It means you can able to capture the entire tumor status. But if you do the tissue based test, what happened? They take a piece of the tissue, let's say they cut here, they stain only these cells. When they stain those cells, they cover only 2 to 3% of the tumor, not even that much. They are able to tell status or response of those particular cells only. Considering the 1%, if they are saying that this is the status. But what happens if you take these exosomes? They come from all these tumor mass together. You take them in the blood, and if you say what's happening, that is more valid, and that is where your sensitivity is very higher. Also, these exosomes comes from each and every type of the cell in the tumor. Tumor means we don't have to think that only cancer cells. It's a population of many cells. Though it starts with only cancer cell, they have T cell, B cell, natural killer cell, fibroblast, endothelial cells, and so many. So these all cells goes wrong once the person crashes the stage 1. So we'll be needing the status of all these cells. For that purpose, we cannot do each and every test to know every cell, how it is behaving. If you do these exosomes from the blood, we can capture what's happening in all over the tumor microenvironment with specific to certain markers related to that. So therefore, we can use them to stratify the cancer. We can see the prognosis of the cancer, and we are able to enhance our ability to understand the disease first, how they are responding to the treatment, and who are relapsing to the treatment, and actually what needs to be taken by the clinician. But all these things are now under still investigational, not reached to the bedside yet. So coming to the therapy part using these exosomes, why we use these exosomes again? So we have several different nano-based platforms. Again, they have a certain kind of specific reasons to use. Since they come from the same cellular source or plant sources, plants also have these exosomes. They're coming basically from the natural sources. When you take the natural thing into body will accept so fast. And also they have less tendency to cause any immune reactions. Let's say you eat some different food, maybe spoiled food, immediately your immune system will reacting, and that is where you see allergy, all those things. But what if you use specifically other chemicals or whatever to deliver? Chemical drug is good, but if you use the chemical molecules to deliver the drug, it has to pass so many barriers to enter the cancer cells. What about the considerations? But if you use these extracellular vesicles, let's say we work on the tomato to take these EVs from the tomato fruit and deliver, tomato we daily eat in our food. If we use that exosome platform as a delivery system to deliver the drug, even if it is not doing something good to the cell, it is not going to do any bad to the other cells. So that is where this exosome concept majorly interesting. And as like other platforms, it also protect the cargo. And another second important advantage is it can cross the blood-brain barrier, which most of the other drug delivery systems have less tendency. These extracellular vesicles tend to cross this barrier and deliver the drugs. Let's say brain cancer, these exosomes based platforms are more effective. In fact, it has shown very good results in animal models. And we can also engineer these exosomes to make it as a more effective, or to add more different drugs to carry into the particular cell. Not only one drug they deliver. Let's say previously we discussed person has to take one chemotherapy drug, one immunotherapy drug, one targeted therapy drug. You can bypass taking these three. If you put three together in this exosome and give it as a single thing, so your three drugs will reach without degradation and entering into the other cells. They go specifically into the cancer cell and release that cargo as a burst. Once they release this cargo, cancer cells start responding to the drug. Maybe it is a negatively, of course. That is why, because of these specific advantages, these extracellular vesicles were extensively studying in the worldwide from past 10 decades. But from past 2 to 3 years, this interest has been increased. I think in India also almost 10 groups are working from AIM, CFTRI, and etc. We are also one of the big group at Apollo Hospitals, Hyderabad, as a research division. We focus mostly on exosome-based platforms to treat cancer. So now we all understood what are cancer exosomes, what is their importance in diagnosing cancer or treating cancer. Now I am going to show the some 3 case studies as a work which we are doing it in our laboratory. With these 3 studies, we will come to know how we can develop a cancer-based diagnostics using this platform, how to treat these cancers using drug delivery, and also one of the interesting thing is they also have certain molecules within them to treat the cancer cells. You don't have to add the drug. they also have capability to stimulate the immunology related things in the tumor system, and that is where they help the cancer drug to work it or make it more effective. That also we will see. These case studies I have split it into three parts. One is related to only cancer diagnosis. Second one is dedicated to cancer therapy exclusively. Third one is related to the drug delivery. So we will see now. So, though we are working on various cancers in our research department, so today I am going to present oral cancer. So, why oral cancer? If you see, number one, we are seeing very good result in the oral cancer. That is one thing. Other than that, this oral cancer is a very good concern and challenge in South Asia, especially. If you compare the worldwide, South Asia have higher number of oral cancer cases prevalence wise. In the South Asia, there is no wonder. India, we have more cancer cases. In India, if we see, northern part of India, they have even more. That is where it has become not only a global health concern, it is also our local base, the importance to study or to develop more of the thing. That is where we have chosen this oral cancer. You might be aware of this all oral cancer, what it is. So it is a formation of lesion within the oral area, and it will start progressing from there. At worst stage, what happens is these tumor cells will go around the body. That is where they cause metastasis and even worsen the condition. We don't have tests for oral cancer. If you see, we have a good histopathology based test, but we don't have the liquid biopsy test. Whatever the done, they are showing very less, like 40 to 50% of the efficiency. Since we are working on these exosome platform, in this study, we try to develop a simple saliva based test to detect or confirm the cancer. So this is how we have made our objective. So initially we have recruited the patients, then isolated the exosomes from them using blood and saliva together. Though saliva is our objective, so we cannot rely completely on saliva, as blood is showing a kind of gold standard. We wanted to compare both and see which is the best initially. Then after confirming that, we wanted to take a particular markers which are in the exosomes to stratify the better or to confirm as a better. Then obviously we done a biomarker analysis and we have done the comparative diagnostics to see which marker is best and which biofluid is best. This is the very brief workflow. Next. So in medical science, whatever the study we do, we have to present in front of institutional ethics committee. So in that committee, we have the doctors, we have lawyers, we have laypersons, we have scientists, everybody. They all should need to understand this protocol. They should give approval to collect the samples. So simply we cannot go and collect the samples. So for that, we need to make a proposal. In proposal, we have to write all these things. So this I'm saying just to know you how to make a IEC protocol to get approval before doing of the any patient related work. That is very important to do ethical research. So without getting these ethical approval, even journals will not accept if you want to publish this data. This is one of the common practice to do any medical research. So this study design is, we can say it as a prospective case control study. We have two different studies. Number one is retrospective. Retrospective means you're not going to do anything as a research. You just collect the data and do some of the trends and find that this is having some kind of abnormality or whatever. Prospective study, we directly involve with the patient samples or patients. We collect their things and we will analyze them. And we have done the comparative analysis of exosomes in serum and saliva to compare. And it is very important to know that with whom you have to get the samples to do this test. Randomly, we cannot go and take who have the oral cancer. We should have a certain criteria. As we are developing the test, we are not confirming them as a cancer or whatever it is. So it is very important. Whom we have included in this study, we should see. Number one is who are already confirmed with the oral cancer by using histopathology. Since it is a gold standard, we taken them, we use these exosome platform and we compared with the histopathology test whether it is matching or not. That is the number one thing we have to do it actually. Without knowing their histopathology status, if we develop a some test, even they are increased, those are not valid. And obviously, we should compare any test we are developing with healthy control. So without healthy control, we cannot say whether it is abnormal or normal. It is with any test, not only the cancer. Therefore, age and gender match controls we have taken actually. Gender also very important to consider because certain proteins, mRNAs are slightly higher or lower when you compare both the genders. So that is where we have taken them, and whom we have to exclude. Sometimes we should not also consider some patients to do this study. If you take the people with other cancers, sometimes people also have two cancers rarely. If you take their samples and do this test, your test will be confused. So you're not able to give any productive thing. We have excluded them. We have not included in this study. And inflammation is also one of the common factor in any cancer. If you take the samples from like rheumatoid arthritis or systemic lupus erythematosus, any inflammatory or immune related people, these markers are already higher within them. If you develop the test using those markers, again it will be a misleading. So you will not get any clear trend. So we have excluded them also. And lastly, very importantly, we have excluded the patients who are not willing to give their consent to use their samples. So obviously, when we go to some people, 10 in 1 or 2, they'll be saying in the cancer black, though they are willing to give, they will have that kind of dilemma that they are doing a lot of tests, they are giving a lot of blood, they'll be treating more often using these strategies. That is where when we go and ask that we are doing some research, give your blood, donate, it will be not helpful to you maybe directly, but next generation in future it will be good. Though internally they want to give, but they say sometimes no, we cannot give, already we have given so much of the blood, since don't have direct benefit we will not give. If they are saying like that, guideline says we should not force them to give the blood, actually we should leave them, so only with their consent we can do it. So them also we have excluded. This is the criteria of our study. And then we have estimated the size initially. Size in the sense, how many patients we have to take? 10, 20, 30, 100, 1,000? How many we should take actually? So being a hospital, people will be coming more often. We cannot go and randomly collect. Let's say 50 comes means we will do this study. That is invalid. We should estimate the cost, how much of the minimum sample required to do this study. You might be wondering now, you can say, okay, if less is not sufficient, you can go for more. Let's say 1,000 sample you take, you do this study. If you do the 1,000 sample, your test itself not working, what is the use of doing 1,000 samples? This is a simple funny cartoon or picture saying that why the sample size is very important. One researcher want to study the average weight of the people particularly living in this area. Let's say this college area he wanted to measure. He simply taken 3 people who are going on the road. He just weighed them and saying this is the average weight of each person, which do not match to any of the population in this area who are roaming. So if he taken 100 people of this weight, 100 people of that weight, 100 people of that weight, they'll be random. If he pick randomly, there won't be 100 of the different weights. There might be an obvious chance that this height, this weight may be 200 people, this weight may be 50, this weight may be 10. That time average will be this kind of, not with that big actually. So that is why we have to estimate the proper size to get the proper data. Go to next slide. So with this size estimation analysis, we found we'll be requiring 40 samples to make a proof of concept that whether it will be suitable to do in more patients or do the validation. If you do in the 40 samples, if there is a trend or we're able to see some difference, then we go for next doing it in more samples. If we're not seeing in these 40 samples itself, there is no use or waste of time to do it in more this sample. This using this strategy, that is where 40 considered as a minimum to get some of the clear trend. So therefore, we have recruited 40 oral cancer patients from the Apollo Oncology Clinic, and we have taken 40 healthy controls who do not have any cancer and willing to give their consent to use their samples, and taken saliva, blood from them. From the cancer patients, we have also taken the tumor piece when they are going for surgery or when they are going for this biopsy test to compare. We have isolated their exosomes from blood and saliva using commercial kits which are available in the market. And we have characterized them, what we have isolated are exosomes using the MISCV guidelines which are reported. And then we go for mRNA analysis within these exosomes, not a cell-free mRNAs, though mRNA test is done everywhere. We have done intracellular mRNA, which are presented within the exosomes, not outside of the exosomes. And data were analyzed to know whether they are potent to stratify the cancer patients initially, and whether they are potent to see any of the prognosis related things. Next. And initially, we have understood the patient characteristics, and we can call this as a cohort characteristics. And again, why it is very important to know all about them other than the size. One researcher is saying his drug is effective in 80%. It is not listed anywhere, just for fun purpose I am saying it. He is saying that his particular cancer drug is 80% effective. How he is saying, if you see, he taken 4 animals. One is within the cage, wherever he kept it is there. And another one is not responded. One rat ran away. With only comparing this responsive rat with the non-responsive control, he is saying it is 80% effective, which is completely incorrect. If he studied all these rats effectively, like what age they are and how many they are, whether they are staying every day or not, all these things, if he has considered into the account, the drug effect will be 30 to 40% because one is responding among the 3. So to not mislead, it is very important to understand the characteristics. Here we can see we have a 40 patients and healthy control. If you see the age, they are more or less similar, 47 and 42 years. And males were higher in the oral cancer patients. Similarly, we have also kept in the healthy controls. Males, we can see both are higher since the oral cancer is majorly occurs in the men compared to women. These are the different sites where they have tumors. And if you see the grades also 1 and 2 are 16, this is 18. Again, if you take grade 1 people 2 and grade 2 people are 30, grade 3 people are 1, again it will mislead like this. Therefore, it is very important. Of course, 3 are less because grade 3 people itself are very less because they are very advanced stage. At least 1, 2 we are matched very much. 3 also we have a required number. We cannot say it is very less, it is a required number. So half of them were metastatics, like 21 people are having metastasis, 19% don't have metastasis. With this, we are able to cover complete spectrum of the oral cancer within these 40 people itself. Therefore, this cohort is more valid to make any test or to develop a proof of concept. So when we go to the data, so any of the molecule you isolate from biofluid or plant particle, whatever, you might be also doing some of the nanoparticle isolation from fruits or fruit peels, etc. You have to know or you have to confirm whether you have isolated or exosomes or not. We have seen in the previous pictures, these are protein lipid vesicles, bilayer structures. Therefore, initially we have estimated the protein lipid concentration within them. Since they are lipid protein particles, we could see good amount of protein and lipid. Again, this protein and lipid very high in the cancer patients than healthy controls. It means they are releasing higher amount of exosomes. It is giving a hint that when there is a cancer condition, these exosomes are released more, maybe to communicate into the nearby cancer cells to make it more progressive. And it is reported that they are within the size range of 200 nanometers, we discussed previously. When we do the size analysis of these exosomes within the particular patients, we can see here figure D, they are within the range of 100 to somewhere around 193. It means they are within a good size and acceptable as the exosomes. And they also have reported that it is having the colloidal nature. How we see the colloidal nature? It is a negative zeta potential we could see here. And since they are vesicles, previously the image which I have shown is it is drawn by us. If you see in the transmission electron microscopy, which is the high-end microscopy, you could able to see these particles as vesicles. Especially you could see in this picture, the side you have a kind of vesicle structure, middle you have a thick some color. So that is where we confirm morphologically what we have isolated are exosomes. And especially since these are the biological particles, it is very important to do certain biomarkers or proteins within them to conform. Let's say some of the proteins also may be in the bigger size that you might be wondering as exosomes. If you take them into consideration, your concept itself is going to be not good. That is where we have analyzed the exosome specific markers using Western blot approach. Western blot is nothing but to see the specific protein expression. If the protein is higher, you will see more color here or band here. If the protein is lower, you see less intensity band here. You could see that serum and exosomes both have the reported biomarkers at good quantity. With this comprehensive biochemical, biophysical, and molecular characterization, we confirm that these are exosomes. Now you might be asking one question, why to do all these things? We can do any 2 or 3. Since these are now at the validation stage, not entered into the up to the market, there are certain guidelines to say these are exosomes. We have to follow that guidelines. Those are called MISCV guidelines, minimum information on extracellular vesicles. Since these are underway, if we use those guidelines and we confirm at multiple extents, we could able to differentiate that these markers we have not done freely from the serum or blood. These are comes exclusively from the exosomes. That is the purpose we have done all these. Yeah, next. Now, coming to the actual our interest, we have screened the I think around 9 biomarkers you could see here. 4 are belong to inflammatory category, 3 are belong to the proliferation category, 2 are belong to the metastatic category, which is nothing but to say in normal terms, inflammation we have discussed as a common factor in cancer. Therefore, we have incorporated 4 inflammatory biomarkers. 3 are related to cancer cell proliferation. We all know that cancer is nothing but proliferation of cancer cells. These 3 proteins have a tendency to cause more and more protein, or we can say other terms, they are responsible for the oral cancer cell proliferation. Therefore, we have incorporated 3 of the proliferation proteins. These 2 are advanced stage markers, MMP9, matrix metalloprotease 9, and chimerin. What these proteins will do is, they make these cancer cells to go into the other places of the body and they make it the condition worsen. To capture the entire status of the tumor, we have quantified the different levels of mRNAs to know the status, what's happening within of the tumor. So you could see here, simply to follow this, there are 1 star means they have a good specificity, and 2 star means they are very good, 3 means excellent, 4 means we can say extraordinary. If we see the actual significance among the inflammatory category, all were good, but TNF alpha is very good compared to other markers. Proliferation category, if you see, all 3 are having very good, because this is the general characteristic of any cancer cell to proliferate. Without inflammation, they may be proliferating, but less. But without these markers, they cannot proliferate. That is where we are seeing very high tendency with 4 stars almost. And when it comes to the advanced stage markers, these MMP9 and chimerin were also significantly higher, but MMP9 are more higher. Why these are higher? If you see, when it comes to our clinical cohort, if we remember, 21 patients are advanced stage. They are contributing to this higher level of expression actually. So with this, we could say that saliva exosomal biomarkers are giving a clear foundation to make a diagnosis of the cancer with high accuracy, but we cannot use accuracy at this point. This is just a simple expression we should do for some of the sensitivity and specificity related tests. Then only we can say it. Therefore, we went to predict actual efficacy using receiver operating curve analysis, which is the test used to judge the sensitivity of any of the tests developed. Yeah. So this is the data. This data is generated from the PCR data, which I have shown previously. When we do this sensitivity analysis, we could see the similar trend as we discussed in the previous slide. TNF alpha has very good sensitivity and specificity of 90-80. SNLP, SAT, YZ1 have above 87% of the specificity and sensitivity if sometimes. SNLP have less specificity, but sensitivity is very high. MMP9 and chimerin were also found to be very good. But if you see one marker from this each category, TNF alpha, OHZ1 and MMP9 were found to be very good. The thing what we have observed here is, if you combine all these three and diagnose in the same patient, the test is more effective. It is showing 85 and 80% of specificity because you are capturing entire spectrum of the disease. If you do the inflammation, you are able to say what's happening related to only inflammation. Do proliferatory if you are able to say only what's happening at proliferation level. But combine these three markers, the effect is more high. 85% sensitivity and 80% specificity means, which is very good of any test, and it is also in the acceptable range. Later, we have also done some of the advanced analysis. It is called sequence specific computing. When you do that, it reveals we don't even have to do these three. With TNF alpha and OH1, two markers itself, we would able to get the same efficiency. If two markers itself are giving the good efficiency, you can simply remove one marker. That is where we come to a conclusion that exosomal TNF alpha and OH1 is better when you do the mRNA based test. Next, what about the serum markers? Saliva is well known for us now. It is showing a very good efficiency, but blood is a universal biomarker system to detect. Since circulation, we have all these markers. Then we compared with the blood. To cut it into the short, if we compare this data with the saliva data, you should see lesser trend of these bars. Specifically, IL-6, IL-8 are more high in the saliva when compared to the blood. These markers, though higher, you could see that compared to the previous data, again, the fold change, if you're seeing in the y-axis, that is very less. And MMP9 and thymorin also high, but only 3 stars you are seeing here. In the saliva data, we have 4 stars. All in all, we would say these mRNAs express low in the serum when compared to saliva, and also some of them were non-significant, IL-6, non-significant in the sense we cannot use them as a biomarker. So that is where compared to saliva, serum is very good when it comes to the oral cancer, since the site is very near. Similarly, we have also done the sensitivity analysis. With this also, we came to know that IL-1 and OH1 biomarkers are very good, but sensitivity is only 75% here. But in the saliva, if you see 80%. So we have a clear thing also to distinguish and say saliva is more effective to use. And other than the analysis, if you're getting a good result in the saliva itself, why to take the blood? Saliva we can collect easily, it is a completely non-invasive, therefore saliva can be taken forward. And also we have checked some of the trends associated with the grade wise. So grade 1 is a lower stage of cancer, grade 2 is a medium stage, grade 3 is very high. These markers which we have analyzed for the diagnosis purpose, they are also showing very good trend in the grade 3. If you see here, grade 3, there is a higher amount of these biomarkers which are reported in the diagnostic value in the previous slide. With this, we confirm that these are not only useful for only the diagnosis, we can also use them for prognosis. They are increased, but increased highly in the grade 3 patient. It means we can also track the disease. That is where we come to a insights of that concept. When we compare these biomarkers with Ln minus means lymph node negative, Ln positive means lymph node positive. Lymph nodes are one of the marker for metastasis, actually higher grade. Between metastasis and non-metastasis also, this biomarker IL-6 was found to be very high. That is where it clearly says that saliva exosomal marker very valid. It will give very good sensitivity and specificity to take this forward into the bedside. Yeah, next. So with this, we came to a conclusion that yes, saliva biomarkers are effective for diagnosing oral cancer with great efficiency of 0.89. It means 89% to say general terms. With that, we not only detect, we can able to grade the patient, we can also able to say the metastatic status. This study just published recently in the Nature Scientific Reports. Yeah, next slide. So now we go to the therapy part using these exosomes. Till now we have seen the diagnostic related thing. Now we'll go to the therapy part, how to use this exosome as a therapy. So for this also, again, as we are seeing more potential in the oral cancer chosen as a cancer type to study them. In this, what we have chosen is, we are talking from initial of this talk itself. These exosomes bring a scoop of the cytoplasm. We'll use them a test. Then we thought, why can't we use those proteins which are coming from these cells as a therapeutic molecules, not as a drug. Let's say, to make it very simple, if they come from the cancer cell, we're able to detect the cancer. But if we use those markers and give to the particular immune cell, why can't we train that cancer cells more effectively? That is where this concept comes into the picture. Since these exosomes have all these biomarkers, they also have a capability to stimulate the cancer cells towards effective sensitization of these chemotherapy. So this is a brief methodology we have followed. Since it is an immunotherapy concept, we have taken the immune cells initially, we have converted them into the more effective immune cells to capture the cancer cells and make them to die. That is nothing but dendritic cells. We have isolated their exosomes and we have tested to stimulate the T cells and B cells. Here we have used specifically T cells. We all know that T cells have tendency to kill any cancer cell, even any of the infectious status, not only in the cancer. T cell, B cell are the first type of the cells react effectively to clear the anything which is in the body, that is including cancer cell. Then we have also loaded the drugs within them to use as a system for giving a synergistic effect. Synergistic effect is nothing but your drug also will affect, your exosome also is going to simultaneously affect. With together, cancers can die more effectively, cancer cells. Then we have validated in the patient samples. So this is the characterization data we have to say they are exosomes. So this we have discussed previously actually, but I wanted to show that how we generate the effective immune cells with a more capability to kill the cancer cells. If we see, initially we have taken these cancer exosomes and treated with these monocytes. If you see from THP1 monocytes to conversion of these TEV mature disease, they are undergoing several morphological changes. It means they have more capability to bind to the cancer cells and kill them effectively. Imagine they are round shaped cells, they have more tendency, they have less tendency to kill the cancer cells. Yeah, I think interest of time, I'll skip some of the deeper details. Yeah, next slide. So this is how, again, we have isolated their exosomes and characterized. And I think, yeah. So this is how our formulations we have tested to see whether they are able to kill the cancer cells effectively or not. You can see by using simple cell death assays initially, when we use these exosome based formulation, if you see that 24 hours, we can see almost the cell death of uh, almost the half of the cells dying by using only 16 millimolar of the metformin drug. But when you load them in the exosomes, 11 millimolar itself enough. It means lesser the drug also, if you load in the exosomes, having the more impact. When you give as a free formulation, cells required more drug to kill the cancer cells. It means it is very good actually. And we have not stopped with only the cell death. We have also tested various functional assays. The number one, we have the colony density assay, which will test the survival of the cancer cell. Person will go to the radiotherapy or immunotherapy, whatever. Initially, cancer cells will die, but they'll come back again. If even 2 to 3 cells are there, that is enough to relapse the cancer. To test that, we have checked the colony density test, which is to know the survival efficiency by testing a single cell to become a very big colony. If they're not becoming a very big colony, yours are more effective. You could see here when you give this exosome platform, they are able to inhibit the clonogenicity. And second one, we have tested the migration potential. Migration is nothing but related to the metastasis. Cancer cells will travel from one place to another place to become more cancer condition. How that it happened? If you see, the migration of cancer cells only going to plays the important role. If you use this formulation, this migration also able to complete. This is 0 hour. You can see there is a very big gap. 24-hour control cells are closed almost. But when we use this formulation, they are at the same place. And figure F shows that more amount of reactivation species to kill the cancer cells. That is where, in all, we would say this exosome-based platform is more effective to kill the cancer cells compared to the exosome drug alone. Next. So this we have validated in the patient samples. This is how it works. We taken the tumor, we made into the slices, and we have developed the primary cancer cells from the patient specific related thing. With that the patient tumor specific cells, we have validated this concept whether they are specifically responding or not. And we have confirmed using the biomarker called CD326 to say they are cancer cells actually. Sometimes we will also take the other cells you might confuse as a cancer cells. So this is how we generated again dendritic cells. I think you can press. It's not coming. Okay, back. Yeah, back. So you can see here, I think the figure is not visible. When we do the clinical assay also, we're able to confirm that these exosome-based platforms are more effective to kill the cancer cells. With this, we have developed a proof of concept that exosomal drug delivery systems are very good. And not only they deliver the drug, they also effectively kill the cancers by themselves. And we can use them as a very good platform. Yeah, please. Next. Yeah, next. So with interest of time, I'll skip this. Yeah. So now coming to the overall conclusion, what we have understood from this, if you see, yes, we can use these nano platforms as a biomarkers to increase the diagnosis detection and to track the disease, number one. We can able to enhance the treatment efficiency if we load the drugs within these particles and give it to the patient. That is what we understood. But they all are in the initial stage right now at the level of proof of concept and research level. To bring them into the bedside, there is a need of lot of validation and involvement of various multidisciplinary people, especially chemistry and chemical engineering people, to develop a variant methodologies for isolating these exosomes effectively, to make it more sensitive and to make it a conjugation studies, etc. This is very much required to bring them into the bedside. We have developed the approach that these exosomes can be used, but how to enhance that will be possible only with the interdisciplinary approach researchers. With this, you can also think that a lot of opportunities also there in the chemical biology, not only in the chemistry exclusively. These are some of the roles. I think academic you might be knowing. If you come to industry, students have a lot of opportunities, especially in the medicinal chemistry, analytical chemistry, to synthesis drugs and scale up methodology developments, etc. Also, you have opportunity in scientific writing to write some protocols or whatever to make a strategies. Where you find all these things, if you see, you can subscribe to this Rasayanika, LinkedIn, Indeed. These are the platforms free to the students or anybody to know the more career opportunities with respect to drug discovery and other chemistry related things. Yeah. Okay, with the interest of time, I want to tell only one word. If you have, though you have a good test, though you have a good treatment, that is not alone enough to reduce your disease. There is a important to know about belief in that medicine that will enhance the treatment efficiency, not only the exosome. If you believe the medicine that is going to work, the systems will work more effectively. Therefore, you will have a better outcome. But if you're not believing, that is called nocebo effect in the medical terms. If you take any medicine, if you're confused whether it will work or not, how much good it will work, I just tested in Madurai, not went to Chennai, all those things, if you think, though drug is effective, that is not going to work for you very well. So believing the medicine, very important than taking the medicine. Yeah, next. Before. So this is a very simple example. I'll stop in 2 minutes. This is a very simple example. This study recently done in UK to confirm this placebo effect. Previously, people were thought we are so foolish. We are just thinking about belief, all those things. What they have done is they have segregated into 2 people who are going for some of the knee pain surgery. After the surgery, one group of people are given for very effective drugs. One group of people given for very low effective drugs. But they have been said that This is the best drug we are giving to you. So your problem is going to solve completely. But those are actually reported for low effective. After 6 months, when they test, the outcomes and the disease reversal were more higher in the people who taken these low effective drugs than high dose of drug. That is where they confirm placebo effect. They also not simply stop. They wanted to know what's happening within these patients. Science is need evidence always. When they do brain imaging, they have found that higher activity in the brain neurons. It means your brain starts thinking more when you think positively. That is where brain start producing through various organs for benefit of the disease reversal. That's what they confirm. So believe in the medicine, not only cancer, any disease. So with this, I would like to acknowledge our beautiful team at our hospital and Apollo, especially Apollo Cancer Institute. We grateful to all patients who are helping us to do all these studies for the benefit of the society. I would also like to specially thank my wife Babiola, alumni of this institute. Yeah. Uh, Thank you very much. I'll be available here anyway until afternoon. We can connect if anything to discuss. We are also encouraged to do any collaborative works at wherever from your end. Yeah. Thank you. Thank you once again.
Thank you. Thank you, sir, for your insightful and thought provoking address. Your words truly reflect that innovation is chemistry in action. To express our gratitude for the successful inaugural session, I invite Dr. A. Anansia Grace, Assistant Professor, Department of Chemistry, to offer the vote of thanks.
How great are your works, O Lord! In wisdom you have made them all. Psalm 104:24. With reverence to the Almighty and gratitude in abundance, I have the honor of proposing the vote of thanks for this inspiring inaugural session. The theme of this conference, Sustainable Nano and AI-linked innovations for next-gen healthcare, captures the integration of scientific innovation, technological intelligence, and ethical responsibility to advance solutions that truly serve humanity. I offer my sincere and respectful thanks to Reverend Dr. Sister Ignatius Mary, our esteemed secretary, whose leadership functions as the initiating reagent, setting in motion a chain of academic transformations that continuously elevate the standards of research and scholarship in our institution. Thank you, sister. I express my heartfelt gratitude to our respected principal, Reverend Dr. Sister Fatima Mary, whose guidance serves as the molecular backbone of our institution, ensuring coherence, resilience, and sustained academic excellence. Thank you, sister. My sincere thanks to the vice principals of Shift 1 and Shift 2, whose administration forms the supporting matrix that allows academic excellence to be sustained and scaled. Thank you, sister. I extend my deep appreciation to Dr. S. Sugumari, Head and Associate Professor, Department of Chemistry, whose scholarly foresight and systematic execution resemble a well-designed reaction pathway, ensuring precision, conceptual alignment, and meaningful outcomes throughout this conference. Thank you, ma'am. A special note of gratitude to our chief guest, Dr. S. Karthik Kumar, for delivering such an insightful and thought provoking lecture on how biology driven nano careers can enhance the specificity, reduce toxicity, and improve treatment efficacy in cancer management. Sir, your presence has introduced a powerful intellectual stimulus, enriching this inauguration with clarity, relevance, and forward looking scientific perspective. Thank you, sir. My heartfelt thanks to all the distinguished speakers whose upcoming sessions promise to act as knowledge activators, enriching this conference with insight, innovation, and scholarly depth. I extend my thanks to all the organizing committee members, student coordinators, faculties, and participants from other colleges whose collective contributions have ensured a successful and meaningful beginning to this conference. With this, I conclude the vote of thanks, confident that the ideas exchanged today will continue to propagate, interact, and evolve long beyond the confines of this inaugural session. Thank you all, and may this conference spark productive interactions and transformative ideas. Thank you all.
Thank you, ma'am. With this, we proceed for the tea break. Kindly reconvene after the break for the technical sessions. You shall assemble inside the hall sharp at 11:45 a.m. Thank you. Dear students, kindly assemble inside the Jubilee Hall fast. The technical session is about to start. I repeat, kindly assemble inside the Jubilee Hall. The technical sessions is about to start.
இன்னைக்கா நேற்று ஒரு ஃபங்க்ஷன் போயிட்டேன் வரல. காமாட்சி அப்படியே
அப்படி வந்தாச்சா அப்பனா? அடுத்து ஏட்டு உதைகள்
எடுத்து பாருங்க 2 மணிக்கு தானே வரும்.
இது மட்டும் இங்க லஞ்ச் சாப்பிடுங்க.
சரிங்க.
சரி ஸ்டார்ட் பண்ணிடுவாங்க. வரட்டும் வரவங்க வரட்டும் ஸ்டார்ட் பண்ணிடுவாங்க.
Knowledge grows when shared, just like electrons flow to create energy. To start with our technical session, I invite Dr. Subimol, Assistant Professor, Department of Chemistry, to welcome our chief guest of the session.
Respected Secretary, Dr. Sister Ignatius Mary, Principal Dr. Sister Fatima Mary, Vice Principal Dr. S. Arul Mary, esteemed Chief Guest, Head of the Department, all other dignitaries, invited speakers, faculty members, research scholars, and my dear students, a very pleasant noon to all. We are indeed honored to have with us today an accomplished young researcher whose academic journey reflects international research exposure, strong scholarity impact, and a deep commitment to sustainable and advanced chemical sciences. The presence of such a distinguished speaker adds immense value to the scientific deliberations of International Conference on Sustainable Nano and AI-linked Innovations for Next-Gen Healthcare, SNAIL 26, and we are delighted that she has graciously accepted our invitation to be a part of this conference. It is my privilege to introduce our invited speaker for this session. Our esteemed speaker, Dr. Babiola Ann Sesuraj, is a postdoctoral fellow in the School of Natural Sciences, Comenius University, Bratislava, Slovak Republic, since April 2025. Her present research focuses on the synthesis of 2-photon absorption benzothiool molecule, an advanced and emerging area with applications in photonics, optoelectronic materials, and bioimaging. This work is being carried out under the guidance of Professor Joseph Noga and Dr. Robaric Peter. Prior to this internal assignment, a speaker served as a postdoctoral fellow at the Institute of Eminence, School of Chemistry, University of Hyderabad, from June 2023 to March 2025, under the mentorship of Professor Rajagomal Nagarajan. During this period, the research was centered on the synthesis of alkaloids using sustainable, environmental friendly, and less toxic methodologies, contributing significantly to the goals of green chemistry and responsible scientific innovation. I'm honored to share that the speaker of this session is a proud alumni, a dedicated undergraduate student of 2012 to 2015 batch. The speaker earned her master's degree from St. Joseph College, Trichy, and PhD from Shastra University. In terms of scholarity, output, and impact, our speaker has 16 publications in peer-reviewed international journals, 8 first-author publications, including 1 joint first-author paper. She has 400 citations and H-index of 11 also, with a strong research foundation in synthetic chemistry, photofunctional molecular design, and sustainable chemical methodologies, and with a growing international publication record. Our invited speaker truly embodies the spirit and scientific vision of SNAIL 2026. Once again, I'm delighted to welcome our esteemed speaker to this platform. I now invite Dr. Babiola and Suraj to take over the session and share her valuable research insights with us. Section over to you.
Good afternoon, one and all. I'm so much pleasure to present all my research topics in front of my UG teachers. I'm little bit nervous and so much happy. I feel like I came back to my home again. So with this, we can start our presentation. Can I get mic? Today, the topic we are going to discuss is sustainable synthesis of N heterocycles for next generation therapeutics. Can change the slides. Actually speaking, this is what Mother Nature is giving us. It is about agriculture, nutrition, many chemicals, and also fiber intermediates and petroleum products, as well as renewable and natural gases, also water, basic from water, oxygen, everything. Whatever we are using, we are getting from Mother Nature. But what we are giving is this pollution and environmental damage, again toxicity. Because of that, we are getting health risk, and also industry is major contributing the disasters, as well as many are misusing the resources. So what we have to do, and also many of the local people, those who don't know about the chemicals or chemistry background or synthesis, the need of synthesis of chemicals. Actually, these are some of the industrial accidents. This major accidents proves our chemistry is very bad. Like that, many people are thinking. This is the major disaster, especially Bhopal disaster. Many people know. So, the next one. Because of these things, we are misunderstanding the chemistry, and also chemistry is essential for this modern life. So, we have to overcome all these drawbacks in chemistry, so that many people, many more years back, they have invented green chemistry. These 12 green chemistry principles, we can focus mainly modern evaluation and also drug synthesis, as well as nowadays industrial chemical process and greener scale up procedures also develop. Based on this, we can reduce the wastage as well as safer solvents and milder condition. Catalysis also reduced, and also renewable feedstocks increased. And if you are coming to industrial chemical process, energy efficiency because of usage of a lower temperature and continuous flow process. Also, catalysis recyclability is the main tool for the chemistry as well as chemical synthesis. And also reduced of toxic reagent and also byproduct. And we have to process safety. That is very, very important. If you are dealing with one chemical,
For example, if you are taking sodium metal, if you are putting it into the water, you will get burst. So safety is very much important. Based on these all green chemistry principle, we have focused the greener way of synthesizing the molecules. Next. Actually, many of the regulatory programs by government as well as funding agency lower environmental impact and safer manufacturing and transparent sustainability matrix, all those things implanted in the industrial side of view. So the principles of green chemistry now coming to the practices, so that we can sustainable and also the practices are increased. The importance of heterocycle in drug discovery. If you are taking a drug molecule, how it is acting? It is acting like a key. Actually, it is targeting the body and it is opening the way of the interaction of the drug into the patient. If you are taking caffeine and penicillin, if you are intaking caffeine we are not taking directly. Actually, caffeine is a drinking product. It is stimulating your brain. Based on this mechanism, all our drugs are working. And also, N-heterocycles bind to biological target very easily because they are having hydrogen bonding, as well as they are fitting into the targets very specifically, and also it builds strong interaction between the drug as well as our body. It is not about environment, but also in the point of our body, sustainability is very, very important. Some of the metal traces along with our drug may damage our body itself. So we have to reduce the metal traces in the drug molecule like palladium, nickel, and other catalysts like copper, gold, all those things. If you are intaking all these residual metals in our drug means, it can lead to the toxicity or organ damage, as well as it can cause the allergies, and also it may increase the cancer risk. These are the recent N-heterocycles for therapeutics. These are in trial phases now. The next one, these things are already approved drugs in specifically N-heterocycle molecules. Based on this introduction, now I am going to present my work from the PhD until now postdoc. This is triflic acid mediated synthesis of pyroxolines. Why? Excuse me. Next. Next. இல்ல ஆக்சுவலா இதுல நிறைய மாலிகூல்ஸ் இருக்கு. இங்க காட்டுதா? கிட்ட சொல்லி கொஞ்சம் லைவ் ஆஃப் பண்ண சொல்றீங்களா? நான் ஒரு தடவை செக் பண்ணிக்கிறேன். மைக்
ஒரு தடவை விட்டதுக்குமா இதுல மட்டும் பேட்டரி மட்டும் மாத்தணும் அப்படின்னு சொல்லிட்டு அப்ப அப்படியே முழிச்சு அப்படி இதுல இதுல சொருக சொல்றான்
Sorry, some technical issues. These are some N-heterocycles molecules which I have synthesized nearly for 10 years work, all these slides. The first work focus on triflic acid mediated synthesis of pyrazolines. While treating phenylhydrazine and aldehyde with styrene, in the presence of triflic acid and acetonitrile as a solvent, we can able to produce various type of pyrazolines. And also I have synthesized mainly the alkaloid in 82% of yield. I think many of the BSc students might have studied about deep eutectic solvents. This is how we have synthesized choline chloride and PTSA as a DES mixture. We can use that as a solvent. Instead of ethanol, methanol or other solvents, we can utilize this as a solvent. It can act as a base for the reactions. Here choline chloride acts as a hydrogen bond donor and PTSA acts as a hydrogen bond acceptor. At a particular temperature, if you are heating, like 80 degree, we can get a molten state. And that molten state called as DES mixture. And this is the proposed mechanism. Initially, phenylhydrazine and aldehyde together forms a intermediate one. Further, it coordinate with triflic acid and also with the styrene, you can get the product pyrazoline. And this is the second work. The extension of first work, oxidation of pyrazolines into pyrazole. Usually, oxidations will happen only in metal or some acids. But here, only with light, I have synthesized pyrazolines to pyrazoles. And also we have studied kinetics of the photo-oxidation of synthesized 135 triaryl pyrazolines. And we have detected pyrazolin uh, only taking place in the presence of solvent, and we have confirmed this is the pseudo first order reaction kinetics. Initially, if you are irradiating pyrazolines into the light, it will convert into the second product, then DCE coordinated through other removal of chlorine radical, then you will get the aromatized product in a proper and high yield. And the next one, iodine mediated one-part synthesis of sulfonylated aminopyrazoles. Under the presence of 90-degree iodine, only neat condition, we have obtained many of the substituted pyrazolines. We have done various phenylhydrazine derivatives, thiol derivatives, aminonitrile derivatives, and we have obtained many substituted thiolated aminopyrazoles. And also we have performed many synthetic applications. We have converted the thiol pyrazole into into various synthetic applications like oxidation as well as removal of NH2. If you are activating this position, you can include many of the various substituent in the pyrazole ring. And also we have conducted various control experiments. Based on all control experiments, we have proposed the mechanism which follows methyl addition and oxidation of thiol. Finally, it leads to the aminopyrazole thiol derivatives. And here comes the core part. We did not use any solvent and any catalyst. Only marylonite K10 catalyst act as a acid surface for this reaction, and we have performed various reactions in the clay K10. While 65-degree, we got only 1, 3, and 5 substituted. If you are increasing the temperature to 110-degree, removal of one molecule leads to 1 and 3 di-substituted pyrazole molecules. And here also various transformation we have done. If you are doing the recycle of clay K10, nearly for 5 consecutive reaction, we didn't get any yield loss. The first cycle we got 96%. Until fifth consecutive reaction, we obtained nearly 86% of yield. So that we can say this as a recycle or renewable resource for this reaction. Based on the many control experiment, this is the proposed mechanism. First double Michael addition will happen, then CC bond formation. After that, aromatization lead to the formation of 1, 3, and 5 tri-substituted pyrazolines. Further, if you are heating up the reaction to 110-degree, removal of alkyl acetate and 1,5 sigmatropic rearrangement lead to the final product formation. And also we have synthesized various spirooxindoles in the presence of only tertiary butoxide. There is no oxidant, only with base. These are the various spiroindolinones. And also I have used eton reagent as a cyclization reagent for this reaction. If you are taking this double bond here, this double bond is restricted rotation. So if you want to rotate the bond, you have to give much more energy. So that you have to heat or you have to spend various catalysis. But here I never see any catalyst or harsh chemicals. Only I have used eton reagent and I obtained nearly 28% of yield. Still it is in optimization stage. The next one is tertiary butyl nitrate mediated acid-free direct nitration of carbozoles. Usually, if you want to nitrate any other molecules, we will be using traditional nitrating agent. These are the reported procedures involved nitric acid, acetic acid, and other copper salts for nitration source. But in my case, I have used only tertiary butyl nitrate as a nitrating agent, and I have obtained various nitration of carbozoles. Based on many control experiment, we have find out that this reaction is going via radical pathway, and also I have done gram scale reaction and obtained 92% of yield. So that I can conclude these procedures we can follow in large scale quantity as well as we can utilize in industrial purpose. Not only with synthesis, I also tried many applications in the field of biological as well as chemical. The synthesized pyrazolines were used as a organocatalysis for CC bond forming reaction. By using pyrazoline as a catalyst, I have synthesized various thiol and CC bond forming reaction with furan, all other substrates, and also we have tried with other pyrazoline catalyst, but the catalyst one which is having hydroxy group worked very well because this is having a resonance stabilization with the structure. And also the other application with pyrazoline, usually pyrazolines has ICT process. ICT means electron charge transfer. This portion of the pyrazoline compound acts as a fluorophore, and this is a electron rich donor. If you are introducing some electron withdrawing group, so the ring current will rotate here so that you will get ITC process in the pyrazoline. And also if you are attaching some of the electron withdrawing groups like 2,4-dinitrobenzene sulfonyl, phthalimide, acrolyl group, these are act as a quencher. And this is the proper preparation synthesis process for pyrazoline probe. If you are taking chalcone with phenyl hydrazine, we will get the precursor 2 in 82% of yield. Then further, the pyrazoline, aminopyrazoline preparation also done with zinc powder and acetic acid, as well as the probe was synthesized in 67%. In the next step, we have tried with various ions like amino acids like methionine and cytosine, histidine, all those amino acids. In that, only glutathione responded very well. Since glutathione is highly reactive, it is sensing only S2 minus ion as well as thiol groups. Other than thiol groups are not reactive with this probe. And also with the collection of urine sample from the patients, we have coated the pyrazoline probe and we have detected only glutathione. The next part is how we can use the thiazole orange and cyanine dyes into the next generation therapeutics. Actually seeing heptomethane cyanine dyes are very active in NIR region. And also we can utilize as a bioimaging fluorescence spectroscopy and also tumor targeting, as well as we can diagnose the cancer. And also photodynamic therapy and optical material and laser purpose also, many people are started using heptomethane cyanine dyes. If you are coming to the part of discovery of the cancer, first if you are doing surgery means you can't remove everything completely. So some of the materials will be left over in the skin. That is will risk of that will give a life risk. And also if you are doing radiotherapy as well as chemotherapy, you will your body will react negatively, and also you will get the side effects more. So in order to overcome all these things, we have to go for other cyanine dyes as well as thiazole orange dyes. If you are looking thiazole orange dyes, these are very important in the DNA and RNA staining as well as apoptosis assays and also fluorescence microscopy and specifically Alzheimer disease research. If you are comparing the traditional dyes with the thiazole orange dyes, they are very focused towards the DNA and RNA. Also, it is targeting very nicely to the focused area. And also, if you are comparing with the signals, this is giving the proper signal. We won't get any negative false signals. Based on previous things, we have designed and synthesized some of heptomethane cyanine dyes as well as thiazole orange dyes in a solvent-free manner, and we have obtained nearly 80 to 90% of yield. These samples are already given for further detection of cancer as well as other therapeutics. In conclusion, we have synthesized environment-friendly N-heterocycles, and also I have used many of the green chemistry principles in my synthesis. And in the point of future perfect perspective, you are seeing it is very stable and solubility, biocompatibility, and also DNA binding, RNA binding are more compared to other dyes. I wanted to acknowledge my professors, Dr. S. Ramesh and Professor R. Nagarajan, Professor Joseph Noga and Dr. Peter Hrobarik for their continuous support throughout my work, and also my friends, family. Particularly, I wanted to thank my husband. After marriage, any woman will face the difficulty actually, but my husband supported a lot. Every time if I tell no, I can't do, means he used to tell no, you can do, you have to go through all the things like that. He used to give a support a lot. And from the starting, my father, he is a farmer actually. He studied up to only 7th, but he guided me a lot. He taught me a lot, and he supported me a lot. Till now, he is continuously supporting me. So, as alumni of this college, I have to thank my professors. I don't have words to thank everybody. This is the... Thank you all. Can you able to find me? Can you able to find me in this picture? Thank you so much.
Thank you, ma'am, for your enriching presentation that has truly added value to our scientific understanding. I now request Ms. Aishwarya, 2nd BSc Chemistry, to propose the vote of thanks.
Respected dignitaries on the dais, esteemed faculty members, distinguished researchers, and dear friends, it is a privilege to propose the vote of thanks for a technical session that was not only informative but genuinely thought provoking. We express our sincere gratitude to Dr. Babiola and Sesiraj for an exceptional technical presentation. Your session stood out for its clarity, scientific depth, and global research perspective. By conducting rigorous theory with contemporary research applications, you have expanded our way of thinking and reminded us that chemistry is an evolving discipline shaped by curiosity and collaboration. We are truly grateful for your time, your expertise, and for sharing your international research experience with our academic community. I extend my respectful thanks to our secretary, principal, vice principal, and head of the department for their visionary and leadership and unwavering support in making this academic event a success. My sincere appreciation to the faculty members for their guidance and commitment, and to the organizing committee and student volunteers for their coordinated efforts ensure the smooth conduct of this session. Finally, I thank all the participants and students for your keen attention and intellectual engagement, which gave this session its true purpose. Thank you.
Thank you, Ms. Aishwarya. If you have any questions, we can ask our chief guest.
Good afternoon, everybody. I am Shivadashni. I am alumni of Fatima College. I am doing a PhD in Alagappa University, Karaikudi. I am from Department of Chemistry only. Sir, you have lead on a very good conference. It's very knowledgeable too. I have two questions. Could I? Sir, considering the chemical design of fluorescent probes and electrochemical biosensors, how can a high sensitivity and specificity is preserved in heterogeneous liquid biopsy samples?
I'm sorry, can you repeat the question? I think echo.
Considering the chemical designs of a fluorescent probe
Okay.
and electrochemical biosensors, how can a high sensitivity and specificity be preserved in heterogeneous liquid biopsy sample?
Okay. It's a wonderful question, but actually it's more relevant to the, what to say, chemistry people. Still, I'll address it. If you do general biochemical reaction, what happens is, let's say you have a test tube, you will be taking whole fluid into the consideration. The readouts, it means endpoint, whatever you read as a reading or fluorescent signal, that will be based on all total the particles which you have. Though you have the particular particle, rest of the things will try to nullify the signal or enhance the signal which is not related to the particular condition. But when you design a particular sensor or these ELISA based thing, what happens is only the specific molecule related to that particular disease or your target of interest will go and bind to that peptides which are synthetically made it on that platform. Rest of the things you will wash away. Final endpoint readouts purely based on your disease specific protein rather than giving from total of pool. That is where you get more sensitivity. That's the
Okay.
thing. Yeah.
So another one question.
Please, please. Yeah.
What is the big challenge in simultaneously optimizing therapeutic cargo loading?
Yeah, it's a really wonderful question, and we are also often facing this problem in our lab. We are half of them into diagnostics, half of into the therapeutic, our lab works. The thing is, as you said rightly, when you have a single drug, what happens is we will load, and when we characterize after drug loading to see whether this drug is particularly incorporated or loaded into the drug, what we do, we take these nanoparticles, we will lyse it, we will detect in the HPLC, and we will see the metformin or whatever the drug interest we load. When we add two drugs, what happens is signals always we will get it confused or they'll mix it. That is where what we are doing currently is we will take the two drugs which having different spectroscopic areas. Let's say one will be in 230 means, another will be at least 300 above. Therefore, we can do these kind of things more efficiently. That is what we're following. If we do not have the option at all, that is where what we'll be doing is we will take the combination drug, we will normalize the data with single drug loaded cargo. Actually, we'll compare the single loaded cisplatin with the double loaded cisplatin and doxorubicin with double loaded doxorubicin. Then normalized data will be considered as a how much of the drug actually loaded within to them in terms of two individual drugs. Yeah.
Yeah, thank you, sir,
Thank
for
you.
your
It's a
clear
wonderful question,
explanation.
really. Yeah.
Ma'am, I have one doubt. You have said that on slide number 32 only I have noted, you have told that without using catalyst, we have optimized your sample. How did you optimize and, and it's stable?
Regarding which molecule you are asking?
I have noted one slide number, so that's
Okay, maybe pyrazole or
yeah, that's
pyrazolene.
pyrazole, I think so.
Okay. Actually, metal-based reactions usually will bond like acid, Lewis acid or Bronsted acid. Based on that concept, we have introduced mild acids like triflic acid, HCl, and paratoluene sulfonic acid. With that surfaces, we have tried many reactions. Trial reaction itself nearly 100. After 100th reaction, we have identified that Lewis acid concept is working. So then based on those identification, again we have various acids. Even if you are taking DES medium, choline chloride and PTSA, there also PTSA act as a Lewis acid. Based on that concept, we have developed metal-free pyrazolene synthesis.
Okay, thank you, sis. Thank you, ma'am, for giving this beautiful opportunity. It's very pleasure to gain so much knowledge from this. Thank you.
Thank you, dear chief guest. With this, we pass for a short lunch break. We invite our honored guests, faculty members, and students to enjoy the lunch arranged. Let us reassemble at 2 p.m. for the continuation of the program. Kindly arrange at 8:02. Okay, ma'am. Kindly reassemble at 1:45 at 8:02. Thank you.